Okay, I'm going to go to the whiteboard to expand this. And the main reason why is that this notation may confuse some people. We do need to learn that, but right now in the beginning, I'm going to go to the whiteboard and explain the way your teachers are probably teaching this to you in your classrooms. All right. So let me do that, and I'm going to do that Pascal's triangle again. So one, 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 two, one, three, three, one, four, six, four, one, 5, 10, 10, 5, and 1. All right? So we're at the level where we need to be. And my question is, what are we doing? We're doing a fifth degree binomial expansion. All right? So I'm going to write this down, what we're going to do, and then I'll write down what the coefficients are. And this is going to be 1, 2, 3, 4, 5, 6 terms now. So let's write down what we're looking to expand. And we're looking to expand this. It's the root of m over n minus 1/2 the root of n over m to the 5th power. Now I'm going to rewrite this as a sum plus minus 1/2 root n over m to the 5th power. All right? And I'm going to write the coefficients down first. I like to write it as a column first because it's easier for me to keep track of everything. So I'm going to write down, 1 times something plus 5 times something plus 10 times something plus 10 times something plus 5 times something plus 1 times something. And let's write this down. So I'm going to start with the first term, which is the root of mn. And that's going to be raised to the 5th power. And then I keep writing it down, reducing the power by 1. First power, and then no power. And then what I do the other one, but I go up in power from the bottom. So it's going to be minus 1/2 the root of n over m. Let's see, 5. It's going to be tough though. Minus 1/2 the root of nm, whoops, to the 4. Let's take a look. Minus 1/2 the root of n over m cubed minus 1/2 the root of n over m squared. It's going to be a tough one, isn't it? And it's going to be minus 1/2 the root of n over m to the 1st power, and then there'll be none. All right, so I'm going to do one at a time. Right, and as I do that, I'll be careful. So it's going to be equal. And that first term is going to be, let's see, m squared over n squared root m over n. Let's keep going. Minus, I'm going to do the number now. That's going to be minus 5 over 2. All right, and then it's going to be m squared over n squared. I went a little too far with that fraction bar. And then you're going to get the root of n over m. All right. Let's do the next one. The next one's going to be 10 quarters, which is 5 halves. Again, what part we did? We did this, we're on this now. I'm just doing the number first. Then what do you get? You'd get m over n, the root m over n. And then you're going to get times n over m. All right? Let's keep moving. I'm not done simplifying. I'm just writing down what I'm seeing. Let's go to this guy. Let's see, it's going to be minus, right? That's 10/8. That's 5/4. Then you're going to get, did I make a mistake there? No, I didn't make a mistake. Let's take a look. M over n. N over m root n over m. Let's keep going. Plus 5. Well, 2 to the 4th, 2 times 2 is 4, 8, 16. Root m over n. Then what are you going to get? N squared over m squared. Last but not least, that's going to be minus 1 over 32. And then we're going to get n squared, m squared, the root of n over m. Now, by the way, I'd be happy for you. I would say you're done for the most part. There's some things you could do. All right, so I want to point out some of the things I'm looking at in the problem. You know, if you wanted to do some reductions, that wouldn't be a bad idea. So let me get my little red pen out. And I want to point out what I mean by that. Conditionally, n's cancel, m's cancel. Let's see, n's cancel, m's cancel. All right, that's not a bad thing. Anything else I can see for simple reductions? Not really. All right. And I'm going to leave it at that. I'm not going to rationalize these guys, but you could. You know what? Let me do that. I think I can do it as I'm just walking left to right in the problem. So let's see. M squared root mn. I'm doing the first term now. N cubed. Minus, let's take a look at this one over here. It's going to be tricky though. There's a 5 m squared root nm, and then the bottom I would get 2 n squared m. And now what do I notice? I notice an m cancels. I'm going to erase this and one of these factors. All right? That's done. Let's go to the next term. Plus 5 root mn or nn, doesn't really matter, over 2n. All right? Let's go to the next one. Minus 5 quarters the root of nm over m plus 5/16. Well, let's put this fraction down now. N squared, the root of mn, then you get n m squared. What happens? Well, there's a cancellation. So let me do that for you. All right, let's keep going. Then what do you get? Minus, let's see what turn you got. 1, 2, 3, 4, 5. Oh, last term. What do you get over there? 132. I'm not done cleaning up either, by the way. N squared, m squared, times nm, whoops, over m. Yeah, I think I'm done. Let me just clean it up a tiny little bit. M squared, root, I'm going to put in alphabetical order, by the way, mn over n cubed, minus 5m root mn over 2n squared plus 5 root mn over 2n. Let's keep going. Minus 5 root mn over 4m. Let's see how many terms we got. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I'm keeping track. And let's read again. Next one. Plus 5n root mn over 16m squared minus n squared root mn over m cubed. I hate to do it to you. I'm going to go further. All right, and I'm going to factor out a root mn, and then what do you get? M squared over n cubed minus 5m over 2n squared plus 5 over 2n minus 5 over 4m plus 5n over 16m squared minus n squared over m cubed. All right, I'm going to stop there. However, if I want to go further, I guess you could get a common denominator if you want to, and you can move forward in that one. But I'm going to stop there. Now, I'm not going to check with the key because I realized in the key I really didn't do much, right? But I'll update the key. I'll definitely update the key, and I'll update the key to reflect this correct answer over here. Okay? Thank you.